Okay, this is going to be the beginning of our optics unit. Optics is kind of fun, it's kind of interesting, there's a lot of uses for it. It's basically how we use lenses and mirrors to form images of objects. And we're going to start out talking about how we see it. Okay? So if I'm looking at, say, a tree, okay, light reflects off that object, off of that tree, and into my eye. So I'm going to draw my eye here. This is side here. Okay, so here's my eyelashes. Okay, there's my eye. The light is bouncing off the tree and into my eye. So I'm going to say light reflects off of objects into our eye. Our brain knows light travels in straight lines. So we see the object back along the path of light. So since the light entered my eye going this way, I know the tree is back that way. So we see the tree in that direction. Now, images form when light gets bent. Our eye, or our brain, still assumes it went in a straight line. So it forms an image in the wrong place where the object is. So a perfect example of that is looking in a mirror. When I look in a mirror, I see myself inside the mirror. I'm not really inside the mirror. I'm seeing myself in the wrong place. That's my image that I'm seeing. So we're going to use this as an example. I'm going to trace a ray of light from my foot, from the observer's foot. It's going to hit the mirror, and then it's going to bounce off and go into his eye. So we're going to label this the actual path of the light. Now, our brain, though, thinks it went in a straight line, so since it entered my eyes going this way, it's going to think it came from back along that line, so it's going to extrapolate back this way, and it's going to actually form an image of the foot back in here, and you're going to see your foot back inside the mirror. Now, we do that for every other point on the body, his hands, his shoulders, whatever, but what we're going to see is that we end up with the image over here. So we're going to label this image. This is the object. Now, when we see ourselves in a mirror, the object is upright, or the image is upright, excuse me. It is the same distance behind the mirror as the object is in front of it. It is the same size. And it's what we call a virtual object, and we'll talk about that more, but basically what it means is the light actually didn't ever get to that point. So the light never gets on the other side of the mirror. Okay, we have a dotted line drawn back there because the light never was actually there, so that's going to be what's called a virtual image. I do want you to notice one thing. If I had a mirror like this, and I had an object that I'm going to label A over here, where is the image going to be? You'll notice over here that the mirror didn't extend down to where the foot was, but I still had its image. So what you do is you extend the mirror down this way. Pretend the mirror is actually going all the way down. Now, the image should be the same distance behind the mirror as the object, so it would be over here. Okay? Label that A prime. Now, if I had an observer up here, so here's his eye. Black reflections. light from this object would hit the mirror and then bounce off into this eye. You would see it back here. So even though the mirror ended here, you can still see the images in the mirror. Off the next page. Now we're going to start talking about lenses. There's two types of lenses we need to know about. A convex lens. Convex means it goes out towards you. It's fatter in the middle. Okay, a concave lens. Concave means it caves in sort of in the middle. Okay, I imagine that if you're here, you're looking into a cave. That's how I remember concave. Now a convex lens is a converging lens. And I said there's some things we have to memorize. We have to memorize that this is a converging lens. What that means is that light comes in parallel, converges, or comes together at a focus. So all these light rays that are coming in parallel to each other here are all going down through this one focus. Now, these can form images. Which are upright or inverted, magnified or shrunk, and real or virtual. And again, we'll talk about that more in a minute. A concave lens is a diverging lens. Instead of going down toward a focus like these do, they go away from a focus. So parallel light diverges or goes away from focus. So if I look at, say, this ray right here, this ray comes in. Now I want you to note it would actually hit this front surface and refract, and then hit the back surface and refract again. But you can treat it as if it's going all the way to the center and only bending once. So it goes to the center line. And then instead of going toward a focus on the right, it goes away from the focus on the left. So it's going to bounce down this way. So that's the actual path of the light. We draw in this dotted line behind it to show where it appears that it came from. Okay. This one here comes in parallel, so it's the midpoint, and then it's going to go down to that focus. Now, there are two ways to figure out where the images are. We can do ray diagrams or we can do math. You need to know how to do both. In this video, we're going to talk about the ray diagrams, because if I try to do both, it's going to be about 25 minutes long. So, when I do a ray diagram, you trace 2 of 3 possible rays. You have to know how to do all 3, but we almost always just do 2. The first one we already talked about. Parallel rays go through the focus. One we haven't talked about yet is that rays to the center go straight. And then the last one is it's the reverse of the first one. Rays through the focus parallel. Okay, so that would look like this. So a ray that went down through the focus like this would get to the center line and then come up parallel to the axis. And then where the rays meet is the image, or is where the image is. So again, we're going to skip the math, and we're going to just jump right to some examples. So you're going to need a straight edge to be able to do this, because we have to draw these rays in nice and straight. So if you don't have one, pause the video and get a straight edge to do this. Now, we're just going to draw in the rays we were talking about. So I've drawn this. I have a 3 centimeter tall object right over here. Okay, 6 centimeters from the lens. You always measure from the center of the lens. So 1, 2, 3, 4, 5, 6. The focal length is 2, again from the center. And you draw the object as an arrow pointing upward. And then I've also put in, not only the focuses, but I put in 2F, because that's going to be a turning point that we're going to see in a little while. Now, I'm also going to draw in a center line for this lens. Because remember, the light will actually refract when it hits the front and the back side of the lens, but I can draw it all the way to the center and just have it bent once. Now, the first ray we draw, I was saying, we draw from the top of the object, parallel. Now, even though that's not going to hit the lens, I can still draw it all the way to the center point of the lens. And then it's going to go down through focus. So we just have to memorize this. It comes in parallel, goes down through the focus. The second one goes through the center, and it goes straight. So those are the two I always am going to draw. Parallel through the focus, straight through the center. The image is where they meet, and you draw it as an arrow going from the center line to the meeting point. So it would be like this. So there's my image. I'll label it I for image. Now, we want to describe it. So the image is, well, it's inverted. The object was pointing upward and it's pointing downward. It is shrunk. Okay, the original was 3 high, and that's obviously less than 3 below the axis. And it is what's called real, because the light does actually get to that point. That parallel ray does go down through the focus. The ray going straight does go down through the center, and the light actually gets to where the image is. Now, I've left a whole lot of space down here to do the math. We're going to go on to the next ray diagram. So now we're going to take it, the object was outside of 2F, it was way over here at 6. Now we've moved it between F and 2F. As I said, that 2F is a turning point. We're going to see what happens. So I'm going to draw the center line in again. Okay. Then I'm going to draw my parallel ray. Parallel goes down through the focus, so parallel to the axis until I get to the midpoint of the lens, and down through the focus. And the second one is going to go straight into the center. So again, it's the same 2 every time. Parallel through the focus and straight through the center. And I have to make these quite a bit longer to get them to meet. So they're going to meet whatever here someplace. So like that. Okay, so I draw my image in from the center line down to where they met. So like so. Okay, so this time the image is inverted. It is magnified. And it is real because the light rays are actually getting there. So this is a projector, right? With a projector, you want a big image that you can put on a screen. You'll notice the image is upside down, though, so when you put the film in the projector, you have to put the film in upside down so that the image flips over and is right side up. That 2F was a turning point. If the object is outside of 2F, I get a small image, and if it's between F and 2F, I get a magnified image. Next one. Okay. Now I move it even closer, so now I'm inside F. So we're going to draw the exact same rays. They're going to go parallel until we hit the center line, and then down through the focus, like so. And then we're going to go straight through the center, like so. Now I have a little problem. These things are never going to meet, so what do? Well, if I imagine an observer, and you don't have to draw this, but if I imagine an observer right here, he's going to think that the light came from back that way. So we can continue the line back this way, okay, but the light didn't really do that, so we're going to draw it as a dotted line. Okay, so it's going to appear to have come from back up this way. And use a straight edge and get it as straight as you can, going straight back this way. The same thing, an observer down here, okay, is going to think it came from back up that way. So we will extend this ray back up this way, try to make it as straight as possible. And it looks like they're going to meet way back here someplace. Extend these back like that until they meet. Then I draw in the object from the center line to where they meet. So this time it's going to be pointing upward, so it's something like this. Okay, so there's my image. So this one is obviously different. It's upright. It's magnified. And this time it's virtual because we had to draw those dotted lines back because the light actually was never in that spot. So when I move the object inside of the focus, that's what I end up with is a big upright virtual image. And that's how a magnifying glass works. If I hold the magnifying close to what I'm looking at, close to the image, I get a big right side up image. Now, lastly, we have to do it with a concave lens. Now, a concave lens may be a little harder to remember, okay, but they're always going to look the same. So that's one thing that's kind of nice about it. So again, we start with our parallel ray. Okay, it's going to go in parallel till it gets to the center line of the lens. But instead of going down through the focus on the right, it's going to diverge away from the focus on the left. But it's never actually back here, so I draw in a dotted line showing me where it appears to have come from, right there. And then I draw a solid line going out from there, like that. So the light actually followed the solid line. It appeared to come from that focus. The second one is just like always, it just goes straight through the center. So I'm going to draw that straight going down through the center. Now where did they meet? They met back here on the left side of the mirror, so right here. So I got this little bitty image that's right side up. So this is upright. It is shrunk. And it is virtual. Because at least that one line is dotted. It turns out any ray I draw, except for the one through the center, is going to need a dotted line on the left side, so it's going to be virtual. So that is ray diagrams for converging and diverging lenses, and our next video will be about the math for the lenses.